Okay, so we are doing 2.4 today. The title is Solving Equations with Variables on both sides. Obviously, both sides means both sides of the equal sign. Okay, so we're just going to do some. We'll slowly work our way up to it and see if maybe we have time to maybe do some on the board. We'll see how it goes. I know, that's the scary part. Okay. Number 1. 2 plus 5k equals 3k minus 6. So when we do these problems, after you write them down, well, there's a 6 and a 5. The best thing you can do is write as I speak, if you can't read that, especially since I really do have nice handwriting, so I can write bigger, but I already use a lot of board. Can change colors. Okay, so when you have numbers and variables on both sides, you see how we have variables on both sides and numbers on both sides, okay? When you do this, you always want to move your variables first because we always just want one variable, okay? So you look at your variables. The 5 is with the K and the 3 is with the K. Most of the time you go, which one is smaller, 5Ks or 3Ks? 3K. That's the number we want to move if we have the option to. So how do I take this 3K and move it over to this side so that we only have K's on one side? Yep, we subtract it. So we're going to subtract 3K just from the K's, right? Because we cannot subtract it from anything else. It's the only thing that are like terms. So left to right, you bring down the 2 because we did not use it. What is 5K's minus 3K's? 2K's equals, what happens with 3K minus 3K? It cancels out. It's completely gone. It's 0, which we don't need to write. And then what do I do with this minus 6? Don't forget the minus with the 6. It's not just 6. It's negative 6, right? Now, do we only have one variable? Now, this is just like we did before. Now, we want to get the variable by itself. Which of these numbers would we move? I know they're both 2. Are we going to move the one with the K, or are we going to move the one that's not with K? Not with. We always leave K for last. So take this 2 right here. How do I move it to the other side? Subtract it because it's positive because there's nothing in front of it. We subtract 2 from 2. Subtract 2 from negative 6. 2 minus 2, those cancel out. We're left with 2K equals, what is negative 6 minus 2? Negative 8. Right? This is just like what we did before. The first step was the only thing that was different. Now it says 2K equals negative 8. Is K by itself yet? No. Completely by itself? No. What's wrong? What's with the K? It's multiplying by 2. How do I get rid of multiplying by 2? Divide by 2 on both sides. Aaron, when I divide by 2 on both sides, what do I get? Negative 4. Negative divided by positive is a negative. Does that make sense? So the first step was the only thing new. After that, it was just like solving a normal problem. Right? Okay. Let's try another one. Number 2. How about this guy? 5a plus 2 equals 6 minus 7a. That one's, it looks longer, it's just I wrote a little bigger. Again, there are variables on both sides, yes? So we need to move one of the variables. Look at the numbers. We have a 5a and a 7a, but that 7 has a minus sign in front of it. Which number is actually smaller, Austin? The 7, because it's negative. Remember, a negative number is smaller than a positive number. So how am I going to take this negative 7a and move it to the other side? Austin? Add it? Yeah, exactly what you think it is. Add 7a to both sides, but only to the a's. So 5a's plus 7a's is what? 12 what? A. What? I didn't do anything with this 2, so what should I do? Bring it down. Plus 2 equals, didn't do anything with 6. Bring it down. What happens with the 7's and the a's? They cancel out. Negative 7a plus 7a, gone. Now that we only have one variable, we just solve to move everything slowly away from a. What are we going to move first, the 12 or the 2, Toops? Look at where I'm at. What am I going to move first to slowly get a by itself? Correct. 12a equals, what's 6 minus 2? 4. Gage, what do I do to get a by itself? Divide both sides by 12. Is this going to be a whole number answer, ladies and gentlemen? No. When we don't get a whole number answer, how do we write our answers? Huh? As fractions. Remember, we should write our fractions top to bottom, just like these are. 4 divided by 12. Does that reduce to a nice fraction? Yeah. What's the answer? 1/3. 1/3. That's a fraction. It's okay. We're allowed to get fraction answers. Now this problem, number 3, is going to be a little different. Okay, I'm going to have 3w plus 2 equals 7w. That's it. That short. I don't let people go to the bathroom while I'm giving notes. This one, do you notice how this 7w is completely by itself? There's nothing else over here with it. Do you see that is what I'm asking. When this happens, you never move that thing. You always want to move the other thing. So you see how there's variables on both sides? No matter what these numbers are, you never move the thing that's alone. You always move the other thing. So no matter which one's greater or smaller, this one's still smaller, so it's fine. But you always move the thing that has more with it. So what am I going to do to this 3w to move it to the other side? Yep, subtract 3w from both sides. 3w minus 3w is gone. We have a 2 equals, what is 7w minus 3w? 4w. Don't forget to say w. Then Gracie, what do I do to get w by itself? What's with the w? The 4. So we're going to divide both sides by 4. The 4's here cancel out. You just have W, because W divided by W is 1. 4 divided by 4 is just 1. What is 2 divided by 4? 1/2. Correct. Does that make sense? So when there's something by itself over here, always move. You want to move everything towards that thing that's by itself, which is still going to happen in this next problem, even though the numbers are going to look a little different. What is different about this one? 1.3c equals 3.3c plus 2.8. What's different about this problem? It's got decimals in it. So, what have we not been using this whole time? Decimals. Here's the fun fact. If it starts with decimals in the problem, your answer can have decimals in it. You cannot actually convert decimals to fractions when that happens. So, you just leave your answer decimal. Now, this one also, see how this guy is by himself? So leave him alone. You're going to have to move the other c. So how do I take the other c, which is 3.3c, move it to the other side? Subtract it. What is 1.3c minus 3.3? Close. -2. Probably subtracted the wrong way. And then we have to put the c next to it. Equals, these 3.3's cancel out. What does it equal? 2.8. Now, what are we going to divide by? No, we never divide by a variable. You're just going to divide by -2 because you're trying to get c by itself. You never divide by a variable ever in your life. So divide both sides by 2. That is negative. So you're going to get c equals the 2.8 divided by -2. You're going to get a decimal, right? You're allowed to have a decimal answer. What did you get, Matthew? Yes, -1.4. Did we also get that answer? Okay. This feel pretty good. Not hard. Mind-numbingly easy. Aaron looks so bored. Okay. Let's throw a step into it. Okay, now we're still going to do the same thing. We're just going to add some parentheses in our problem. So we're just going to add an extra step every once in a while. Okay? We just did 4 of them, so this is number 5. First problem, 8s subtract 10 equals 3 parentheses 6 minus 2s, close your parentheses. Now, when parentheses are in the problem, what do you have to do first? The parentheses. How do we do with parentheses? What's that called? Distributing. What operation do we use when we distribute? Multiplication. So we're taking the number that's on the outside of the parentheses and multiplying it by only the numbers on the inside and just bringing the variables with them. So did we do anything to this left side? Is anything going on over here? No. So we're just going to bring it down. 8s minus 10. Leave that alone. Now over here, 3 times 6 is 18. Then I take this 3 times this -2 because it says -2. And -6. And since it had an s on it, I need to keep the s. Now it's just like we just did. Do we have multiple numbers on both sides? Yes, so we're going to move the smallest value of s's to the other side. Joy, which one's smaller? -6 or 8? Smaller. -6. How do I take this -6 or -6 and move it to the other side? Joy? Yep. Yep, plus 6s to both sides of the equal sign. Remember, we can add and subtract s's in variables. We just cannot divide them. So 8 s's plus 6 s's is how many s's? 14 s's. Bring down everything we did not use. What happens with the -6x and the plus 6s? They cancel out, so then they're gone. Now we only have one variable. What do I do next, Toops? What do I do next? Okay, add 10 to both sides so they're like numbers. Bring down 14s equals, what's 10 plus 18? 28. Crystal, what do I do to get s by itself? What's with s? What number's with s? So we should divide by 14. That's the number we should put on the bottom. So anything divided by itself is 1, which means we just have one s or just s. What's 28 divided by 14, Crystal? 2. Nice whole number. A little extra work, but not that bad. Gonna have to write this one here. How about number 6 then? 7 parentheses x minus 1 close your parentheses equals -2 parentheses 3 plus x. Close your parentheses. It's a little smushed. What's different about this problem? There's 2 sets of parentheses, so you have to distribute twice. So do one side at a time. Take the 7 and multiply it by the numbers. So what number is actually in front of x if we don't see it? 1. So what's 7 times 1? 7, and then it has an x, so we keep the x. Then what is 7 times -1? -7 or -7. Then do the same thing over here. What is -2 times 3, Chad? -6. And then -2 times 1, -2, and we're going to keep the x with it. Now again, it's just like the last problem. There's variables on both sides. Which variable are we going to move? The 7x or the -2x? The -2x. How am I going to move it to the other side? Yep, plus 2x. Plus 2x. So what's 7x's plus 2x's? 9x's. Bring down everything. So bring down the -7, the equal sign, the -6, the -2x and plus 2x cancel out. Now again, 1x. Now move everything slowly away from it. What number am I going to move next to there, Chad? The 9 or the 7? The 7. How do I move the 7 to the other side? Add it. So 9x equals, what's -6 plus 7? Huh? Just 1. How do I get rid of 9 times x? Divide by 9. What is x going to equal? What's your final answer? 1/9, the fraction. 1/9. A lot of the time, a lot of the time, your answer is in the problem. You see how you would have typed that in and then went, oh, it gave you the right answer? A lot of the time it's there. Okay. Challenge problem. How about, yep, I'm going to give you one of these because the last problem in your homework's kind of like it. Number 7, 6 parentheses 5m minus 3, close your parentheses, equals 1/3, the fraction 1/3, parentheses, 24m plus 12, close your parentheses. The good thing is, I know that fraction looks scary, but it will cancel out when you distribute. So distribute the left side, practice plugging in that fraction, multiplying it by your whole numbers. You will get whole numbers. So distribute. I'm going to do it slowly. I'm just not going to talk through it. Try to work it out on your own and just look up as you need. Did we get the same answer? Was that not so bad, other than, you know, a little bit with the fraction again? Okay. Really quickly, I'm going to fix this because I don't like it. I'm going to change your homework just like a smidge. It's going to be 10 through 18, so I took one away. I'm going to add one. I'm switching the math. I'm going to do number 25. Because that, we're going to practice something in just a second that's different. And Miss Weave already left, but we're going to have to tell Miss Weave because she already wrote it down this morning. So I just did 10 through 18. It was 19, so I just stopped at 18 and then did number 25. Okay? The reason for that is we're going to talk about special solutions. I'm going to show you them in a very, very generic way, and then we'll do a practice problem, and then we'll stop with the recording of the notes, then we'll do some practice problems, okay? And for those of you, that will be the end of official notes, and then you can use the restroom. Okay, so special solutions. You see how everything we've done so far, we've gotten a variable equals an answer. We've got one answer. That means one solution. We've got something. These special solutions are going to have word answers, which is why I gave you 25. Okay? So let's look at an example. Number 8. I'll make it real basic for you. 5x plus 3 equals 5x minus 7. Huh? No. We're just going to solve it just like normal. Now, how do we solve this problem? Let's just talk through this, right? We have multiple numbers on both sides, right? Don't we always move all of our variables to one side? Don't we usually pick the variable based on which one's the smaller one? Well, what do you notice, Gracie, about our variables? They're exactly the same, so it doesn't matter which one I move, right? So if I say, hey, I want to move all my x's to the left, what happens when I subtract 5x from both sides? If I have 5 x's and I take them away, what happens? I have none. I have no x's. So should I write any x's in this problem? No, because these cancel out, don't they? So what's the only thing left over here? Just 3. Over here, what happens with these x's? Same thing. 5 x's take 5 x's away. They're gone. What's the only thing left on this side? -7. Now I have a question for you. This is a basic math question. Is 3 equal to -7? Is that true? Is 3 the same thing as -7? That's not true, right? Okay, well, so in my mind, I'm thinking this is not true, right? This is not how we write our answer, but this is what I think in my head, right? This is my little thought bubble. So when something's not equal or not true, we put a little diagonal slash through it, but there is a word answer to it. This is a very terrible word bubble, right? If I was thinking this. There's me. Give me some hair. Okay? Aren't I pretty in sixth form? Yeah. When something is not true, so this could say 5 equals 100. Is that still not true? Yeah? Okay? Anytime this is not true, we write no solution. Because there's no answer. Nothing is going to make that true, is it? Nothing's going to make 3 equal -7. Right? Okay. Now let's look at a very similar problem. Number 9. That doesn't look like an I, looks like an A. Okay. How about 7A plus 3 equals 7A plus 3? Again, right here I can see the answer, but it's okay. You have variables on both sides, yes? Gracie's going to tell me that they're the same. So no matter which one I subtract, because they're both positive, if I take away 7A from both sides, what happens? They cancel out again, don't they? So what's left on the left side? 3. Got an equal sign. What's on the right side? Now I have, what's my thought bubble going to say? Is that true, Morgan? Is 3 equal to 3? Yeah. My thought bubble is saying it's true. Does anyone have a guess on what the answer is? If it is true? It's not yes solution. That is a good guess, but no. That's a word for equal sign. But you know what? I like your thought process there, Josiah. Anyone know? You have learned these words before. If I give you the symbol, maybe it'll help. This is the symbol. It's like an 8 sideways. Infinite! It's called infinite solutions. solution or solutions. So the correct word answer is this guy, infinite solution. It's called infinite because as long as a number equals itself, it's true. So can't any number equals itself? That means any number means infinite numbers equals itself. That's why it's infinite. Does that make sense? So based on what your thought bubble is, tells you what you're going to write as an answer, okay? And we're going to practice one because sometimes they start out looking like this and they require a lot of work, but in the answer, in the end, it's a word answer, okay? Let's try it. Let's try this guy. I don't even remember what number I'm on. 10. 5x plus 5 equals 3 parentheses 5x minus 4, close your parentheses, and then minus 10x. They always do this to you. They always add a little extra just to confuse you. So just like a normal problem, I see parentheses. I look at them first. What are we going to do? Distribute. Deal with that first. So on this left side, we did nothing to it. So we're going to bring it down. 3 times 5x is 15x's. 3 times negative 4, negative 12. What do I do with this minus 10x? Bring him down because I didn't touch him, right? Now, this is where they confuse you. Look at the left side. Always do this first. Are there any like terms on this side of the equal sign? Do you have any in common? 5 and 5x and 5? Because one has an x, one doesn't, right? But this side, are there any like terms? Do anything have similar outsides? Yes, these x's, right? Now, this happens almost every time because I try to throw a wrench at you, okay? When they're like terms on the same side of the equal sign, you do exactly what it says. Same side, same signs. So 15x's minus 10x's. So do exactly what it says. What is 15x's minus 10x's? Because the 12 doesn't matter. 5x's. So I added these together, 15x's minus 10x's. I bring down the thing I didn't use, minus 12. Well, since I didn't do anything to the left, I'm going to bring them down. Now, this is just like the one we started with earlier, isn't it? Yes. Right here, can you kind of see what your answer is going to be? Yeah, because what happens when I move all my variables to one side? They cancel out. What am I left with? What's on the left? Negative 12. You are not done until there's one number on each side, okay, ladies and gentlemen? So if you had 2 numbers over here, that means you have to simplify them. So my question, my thought bubble, is it true or not true? So what am I going to write as an answer? I'm going to put a line through it, and I'm going to write no solution. Does that make sense? Right? They always do this to you, whether it has an X or not. They're always going to throw an extra combining like terms in there. Okay? You ready to try these on the board? I know you don't want to, Joy, but you're gonna. Okay. I'll stop this once I can